in case of your RPVST plus, RSTP or MSTP, election process is very interactive because in these protocols we are using the concept of
Proposal agreement.
proposal and agreement,
Yes.
right? So now while you are configuring RPVST plus, RSTP or MSTP, you can please take care of one thing, that RPVST, RSTP or MSTP are using concept of as port and non as port.
Okay.
The switch ports connected with the
Devices and
machines.
machines.
Proposal is not
It's not sent on those ports.
on the as port, right? The switch never send a proposal message on the as port.
Yes.
But how you will define the as ports?
With a port first command.
Yeah. Need to configure port fast feature. If you will not enable port fast feature, your port will be treated as known as port.
Okay.
And it will take around 30 seconds to come into the forwarding state.
Okay.
Right?
Yes. Yes.
Known as port.
Port first.
The switch port connected between
Switches.
switches. Is being sent on those ports. Proposal and agreement is being sent on those ports.
Those ports. Yeah.
We send proposal message as well as we send agreements. So if you have the superior BPDU, I'll send you a agreement also. But first of all of the switches will be sending proposal to each other. And if you are receiving superior BPDU, then you will send agreement to me as well.
Okay.
So please make sure that you have enabled port fast while you are configuring RPVST plus, RSTP or MSTP. Okay.
Okay.
Port fast is required.
Okay.
Yes. Anything else?
No, thank you. Understood.
Okay. Now today we are going to discuss about Etherchannel.
Okay.
Yeah. You know what is Etherchannel?
Yes, Etherchannel is a process of bundling physical network ports into logical bigger bandwidth capable virtual port or
All right.
logical port, if we can put that.
So let me summarize it for you. Etherchannel is a now give it a read, please. Yeah.
Okay.
You can see Etherchannel is a link bundling technology used to aggregate multiple physical links together in order to increase the total
Throughput.
throughput.
Okay.
Okay.
Yes, got it.
Initially, it was our this technology is developed by Cisco initially.
Okay.
Okay.
Yeah.
You can bundle limited number of
Links together.
together, right?
Yes.
So basically, if we follow the architecture, this is my access layer switches, and here I have the distribution layer switches. All right.
Yes.
What I did, I have connected the switches in the redundant manner. That in case if one of the link goes down, other link is used to forward the traffic. So this is switch 1, this is switch 2, this is switch 3, and this is switch 4. So I've connected switch 3 with switch 1 and switch 2 both. Likewise, switch 4 is connected with switch 1 and switch 2, right?
Yes.
But the problem is STP is there. So if STP is there, for example, switch 1 is the root base. This port will become RP, this port will become alternate.
Yes.
RP, DP, DP, this port will become RP, and this port again will become
alternate.
Only we have one link in the use, right? So if I have users here, for example, I have 50 users.
Yes.
And this speed of this link is 100 Mbps.
Okay.
So you know that if all of the users are sending traffic, they'll have 100 upon 50.
Yes.
2 Mbps each, right? And you cannot utilize the full bandwidth. So the user will be getting 5 Mbps each.
Okay.
Right? That's why we have uplinks. We don't have the same link connected between switches. So most of the time we have the 1 Gbps link or 10 Gbps link. So if I say this is my 1 Gbps link, 1 Gbps link is having 1000 Mbps. If I divide it to 50,
20.
so around each user will get, you can say 17 to 80 Mbps, right?
Okay. Yeah.
Because this bandwidth of this link is
shared.
But in case if I want to increase the total bandwidth, So what I did, I said, okay, let me connect one more link. This is what I think, right?
Yeah.
If I'll connect one more link, we will have 1 Gbps. So now we have total 2 Gbps.
Yeah.
2000 Mbps divided by 15.
Mhm.
You can say 40 Mbps. Each user will get around
38.
But this is not true. If you are running STP, what STP will do?
A block.
This port will become RP and this port will become alternate. So theory, by adding
No links.
right. See, what theory is saying? Theory is saying that if you add more links, you can increase the total throughput, right?
Yes.
But what is the truth? Truth is STP will block all the redundant links. So if I give you a simple scenario here, for example, if I have two switches, see this is not a valid design, but for example, if I have two switches, I have connected two links, right, Kavasto?
Yes.
1000 Mbps of each means 1 Gbps.
Yes.
So we have two things here. First thing is we have bandwidth, right?
Yeah.
What is bandwidth?
The high speed first.
Possible rate of
Data. Okay. Transmission.
what is bandwidth? Highest possible rate of data
Transmission.
transmission. We have one more thing which is known as throughput, right?
Yeah.
If I say this is a full duplex link, full duplex means you can send and receive at the same time, right? It means I can send by 1000 Mbps and I can also receive at the same speed. It means if I have 1 Gbps link as full duplex, so total throughput can be
2 Gbps.
2 Gbps, right?
Yeah.
Why? Because you can send 100 and 1000 Mbps and at the same time you can also receive at the same rate.
Okay.
Yes or no?
Yes, that's true.
But if it means if I'll add more links, if I'll add 3 and one more, 4 links, of each of 1000 Mbps.
Yes.
So I am expecting that if I have 4 links of 1000, I have total
4 Gbps.
bandwidth, right? If I multiply it by 2, 8000 Mbps of what?
Throughput.
But that's only in theory. The truth is like this is my DP, this is my DP, this is my DP, this is my DP. This become will RP. For example, this is alternate, and this is alternate.
Yes.
So I'm getting only 2000 Mbps of throughput. I was expecting 8000, but I'm getting 2000 Mbps of throughput. That's the problem with STP because STP will block the links.
Yes.
So that's why we come up with the idea of
bundling Etherchannel.
Etherchannel. So what is Etherchannel now? Like we have discussed, Etherchannel is a link bundling technology used to aggregate multiple physical links together in order to increase the total throughput. So if I have 4 links connected between switches, one, two, three, 4. This is my switch 1, this is my switch 2. So each of link is having 1000 Mbps of bandwidth, means 1 Gbps link. Right?
Yeah.
So if you will expose all of the links to the STP, STP will block all the redundant links. But what we did, we have bundled these links together. If you will do this, this is my switch 1, this is my switch 2. Switch 1 is connected with switch 2 here, and now as per the STP, we have only one link here, which is known as port channel.
Yes.
Right? See, physically we have total 4 links, each of 1000 Mbps. But virtually we have bundled all of the links together, and now we have only one link, which is known as port channel. Now STP will be running on this.
Yes.
So STP will say, okay, between switch 1 and switch 2, we have only one link. And we can't block this interface. So we can't block it, right? If you can't block it, means you will be, all the interfaces are in up and forwarding state. But as per STP, there's only one link.
Yes.
Right? So,
yes, understood.
Yeah, understood. Very good. How to bundle links, right? For that, we have 3 options. First is
On
mode. Second is PAGP. And third is
LACP.
PAGP stands for port aggregation protocol. LACP stands for
Aggregation control.
link aggregation
Control protocol.
control protocol. Link aggregation control protocol. See, the PAGP is, you know, that PAGP is Cisco proprietary.
Yes.
And LACP is
Open standard.
open standard. But before bundling the links, we got some prerequisites. Duplex must match. Bandwidth must match. If access port, they must be
access on process.
Member of a same VLAN, right? Okay. If you're bundling 4 access ports, and first two access port are VLAN member of VLAN 10 and next two ports are member of VLAN 20. The switch will not allow you to do it.
Okay.
Switch will say you can't bundle these links together because first two link belongs to VLAN 10 and second two links belongs to VLAN 20.
Okay.
Okay. And then if you say if trunk ports, the allowed VLAN list must be
Yes, sir.
same. For example, this is switch 1 and you are bundling two links together. This is switch 2. And both of these links are in trunk mode. Trunk. On this user is VLAN 10, this user is in VLAN 20, VLAN 10, VLAN 20. So what you did, you said that VLAN 1, 10 and 20 is allowed on this link. But on this trunk, VLAN 10 and 20 is allowed. VLAN 10 is not allowed. So you can't bundle these two links together.
Okay.
Right?
Yes.
Because if, for example, if this link goes down, this interface will not be forwarding traffic for VLAN 10.
Yeah.
So that's why if you're bundling access port, they must be member of the same VLAN. If you're bundling trunk ports, the allowed VLAN list must be same. Right?
Yeah.
And the last thing is all switch ports must be connected with same switch on the other side. Right?
Okay.
Because if I say this is my switch 1, okay, Kauvastu?
Yes.
This is switch 2 and this is switch 3. In this case, you cannot bundle these two links together.
Okay.
This is not possible.
Okay.
Because these two ports belongs to switch 1, that's true. But on the other side, one link is connected with switch 2 and other link is connected with switch
3. Yeah.
3. So you can't bundle them together.
Okay.
There are a few prerequisites before you start bundling the Etherchannel, or sorry, before you start bundling the Ethernet links.
Okay.
Please make sure that duplex is same, bandwidth is same. If access port, they must be member of the same VLAN. If they are trunk port, the allowed VLAN list must be same.
Okay.
And all switch ports must be connected with the same switch on the other side.
Exactly.
Right?
Yes.
Only then you can bundle these links together. Now, on the configuration point of view, you have total 3 methods. First is
On mode.
Second is
PACP.
PAGP, and third is
LACP.
LACP. So manual method of link, no negotiation, comes between switches. Okay.
Yeah.
On both
switches.
And goes in. Sometimes it can cause a temporary loop. Sometimes. Okay.
Okay.
Minimum to end. Minimum 2 and maximum 8 links can be bundled together.
Mhm.
If we talk about PAG, this Cisco proprietary
Mhm.
protocol. Those switches will negotiate
Negotiate. Okay.
with each other. Never cause a loop in the topology.
Mhm.
Minimum 2 and maximum 8 links can be bundled together.
Mhm.
PAGP modes. In PAGP, interface can be configured in one of the two modes. PAGP auto,
Desirable.
PAGP desirable, right?
Yes.
Wait for other side to
To negotiate.
initiate, right?
Yeah.
Actively start the
Negotiation process.
negotiation process. PAGP desirable doesn't wait for any like negotiation to happen.
Okay.
Then last we have the LSAP.
Mhm.
It is an open standard protocol.
Mhm.
Those switches will negotiate with each other. It never goes a loop in the network. Minimum 2 and maximum
60.
minimum 2 and maximum 16 links can be bundled together.
Mhm.
LSAP modes. LSAP active and
Is it
LSAP
passive? Passive.
is like PAGP desirable.
Okay.
Is like PAGP
Auto.
LSAP allows you to bundle minimum 2 links and maximum 16 links.
Yeah.
But always remember 8 links will be created.
Okay.
Will remain in 10 by state. 8 links will be active at a time and other 8 links will remain in
Standby mode.
10 by state. Okay.
Okay.
This is how it works. On mode, PHP and LSP.
Yeah. So because the protocols they don't cause loops, is it because of if the port channel is not configured correctly between the two switches, the ports become error disabled?
No, the
On
ports will be working as independent ports.
Okay.
See, in case of auto, if you make the configuration on one switch, the switch will start acting as a port channel.
Okay.
Okay, but on the other switch, the interfaces are still working as an independent switch ports, right?
Okay.
This situation might cause a loop, but in case of PAGP, for example, you have done the configuration on one side.
Yeah.
Switch 2 configuration is still pending. So in this case, ports of switch 1 will be acting as independent port.
Okay.
Yeah. And we'll discuss it right now, okay?
Okay, no problem.
So that's why you should always avoid the on mode. So basically, if you know that this is switch 1, this is switch 2, right?
Yeah.
You know it already. This is switch 1, this is switch 2, and switch 1 is elected as the root bridge, for example. And this is switch 2, and switch 2 is a non-root switch. So switch 1 will be sending BPD on both of the interfaces, on this and on this, right?
Yes.
So this port will become DP and this port will become DP. But on switch 2, this port will become RP and this port will become alternate. But still switch 1 is sending BPD on both the ports.
On
both the ports. Right?
Yes.
So as long as switch 2 will keep receiving the port, this port will remain in RP and this port will remain alternate. Right? But once you bundle the interfaces using the on mode, you will make the configuration on switch 1 first, right?
Yes.
You will make the configuration on switch 1 first. Switch 1 will start treating this both of the interfaces as a single switch port. Now what switch 1 will do? Before switch 1 was sending 2 BPDs, now switch 1 is sending only 1 BPD.
Okay.
For example, it is sending BPD out of this interface.
Okay.
Now switch 2, this port is expecting a BPD but not receiving a BPD, right? So what this switch port will do? After a few seconds, this switch port will become DP, receiving BPD from this port and sending BPD off.
Yes, to the other port. Okay.
See, you have learned STP in the CCNP as well. And you know one thing, right? In spanning tree, if a switch port is participating in STP, either it receive a BPD or it will be sending a BPD.
Yes.
The port cannot be in idle state. Like if you are not receiving BPD, you have to send a BPD.
Yes.
So that's why in SCP we have 2 port roles, designated and non-designated. Designated means the port who sends a BPD, non-designated means switch port who receives a BPD.
Okay.
But once you bundle the port channel, you have 2 interfaces, but switch will be sending BPD out of only one switch port.
Yeah.
When switch 1 will start sending BPD out of one interface, but switch 2 ports are still operating as independent, right?
Independent ports.
Switch 2 is expecting 2 BPDs but receiving 1 BPD. So this port will be turned to BP and it will start sending BPD back to switch 1. Here we have a
loop. Okay, makes sense.
That's why it is always recommended to avoid on mode.
Okay.
Because when you use, for example, LSEP or PHGP, you have done the configuration on switch 1, but still the both of the interfaces will be acting as independent.
Okay.
And switch will be sending BPD out of
Both
interfaces. Okay.
Yes.
Until unless you make the configuration on switch 2 side, then the bundling will happen.
Okay.
Yeah.
Understood.
Understood?
Yes, thank you.
Okay, very good. You just give me 1 minute. I'll be back.
Okay, no.
Okay. Yeah, so
Yes.
now you know that I said it can cause a temporary loop, right?
Yes.
You know, but this is temporary loop, not a permanent loop, because in spanning tree, while you are configuring Etherchannel, we have a concept known as
Let's config. Okay, yes.
channel misconfig guard. Which feature is used to detect loop created by the
Channel.
Etherchannel configuration.
Okay.
Etherchannel misconfiguration. Upon detecting a misconfiguration situation, the switch port will be upon detecting a misconfiguration situations, the switch ports will be moved to add a disable state.
Okay.
Okay.
Yes.
Yeah. All right. Now, let me start the VMware so that we can see the basic configuration. Can you see the topology? Also?
Yes,
Hello?
yes, I can see the topology. Yes, can you hear me? Hello?
Yeah, can you see the topology?
Yes, I can.
Okay. Bipole nodes so that we can make the configuration from scratch.
Okay.
Start all nodes. Would be visible to you?
Yes. Visible?
Yeah. So you can see this is my switch 1. Enable configuration mode hostname switch 1. Enable configuration mode hostname switch 2.
Okay.
Okay. First thing that let me check spanning tree protocol. Show spanning tree summary. You can see on switch 1 by default which STP is in operation PVST.
Yeah,
Switch is in PVST mode, right? If you want the fast conversions, you can change the spanning tree mode. Spanning tree mode, MST, PVST, or rapid PVST.
Rapid.
Right?
Yes.
MST, PVST, and rapid PVST. So let me change it to, for example, rapid PVST. Spanning tree mode, rapid PVST. Okay. Now, show spanning tree summary. Okay. So now switch is in rapid PVST mode.
Yes.
You can see that configured path cost method used is
short.
But long method is there because you know that we have two types of metric. In short, it is 16 bits long metric. And when the long method is configured, in that case, your metric length would be 32 bits.
Okay.
Sometimes in lab, see, you'll always see that in lab exam, the questions are always be like tricky questions.
Okay.
Okay. So they will never ask you to configure rapid PVST directly. They'll not say ki, enable rapid PVST. Okay.
Okay.
They always try to be like putting it in a tricky way. So they'll say enable STP version who is having 32 bits long metric.
Okay.
Or which is also known as long method. So you can see spanning tree, path cost, method. We have two methods. One is long and second is short.
Short.
So you can see the difference. In long, use 32 bits value for default port path cost. And in case of short, use 16-bit based values for default port path costs.
So Cisco prefers that we use the short method?
No,
or
it's up to the
the
protocol.
choice? Okay.
Yeah. Because if you remember, STP cost, port cost. We have Ethernet link, right? For Ethernet, cost is 100.
Yes.
For fast Ethernet, cost is 90.
90, yes.
For 1 gigabit Ethernet,
Still 190.
What? 4.
Is it still 90 or 4? Okay.
For 10 gigabit Ethernet,
Should be
cost
1,
is 2.
2.
What if I have 40 gigabit link?
Still 2.
Right? Otherwise, the metric value will go into minus.
Minus. Okay.
Because if you can see that if the bandwidth of links is increasing, so cost value is decreasing.
Yes.
Cost value is decreasing along with it, right? So that's why this is the sort method. That's why we come up with the idea of
long method.
Because we need to calculate metric value for high speed links like 40 gigabit, 100 gigabit links.
Yes.
Okay.
No, understood. Yes.
That's why we need this long method, and that's why the newer version of protocols like RSTP, MSTP, RPVST plus, all of them are using a long method for metric calculation.
Okay. Okay.
Yes. So now you can go to switch 2 as well, or you can see show spanning tree summary. This mode is enabled. Rapid PVST, right? This switch is root bridge for VLAN. None.
For none.
Because by default we have only one VLAN. This is VLAN 1. So you can see here switch 1 is root bridge for VLAN 1.
Yes.
You'll say why? Because you can compare it here. VLAN 001. This bridge is the
root bridge.
Because of lowest base MAC address. This is the base MAC address of switch 1. This is the base MAC address of switch 2. AABBCC002000. And on switch 1 we have 1000, right?
100.
That's why switch 1 MAC address is lower one, so switch 1 has elected as the root bridge.
Yes.
Now we have used only 4 links: E0/0, 0/1, 0/2, 0/3. And 2/2. So let me disable all the extra ports. Do show spanning tree. Interface range Ethernet 1/0 to 3 and E 2/0 to 1 and then E 2/3 because 2/2 is in use.
Yes.
Same thing on switch 2, 2 switch 3. OP. and paste.
Okay.
Now you can see in this topology, we have total 5 links. Show spanning tree. 4 interfaces are connected between switches, and this interface is connected with the end user.
Device.
If I go to switch 2 now, you will see that these 3 interfaces are in blocking state. DP, 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 and DP. This port is RP, this port is alternate, and alternate. DP and DP. So you can see it now. Now we are going to bundle these links together.
Okay.
Okay.
Yeah.
So if we go to the switch 1 and we use the on mode, interface range Ethernet 0/0 to 3. Channel group 1 mode. You have total 5 modes.
Okay.
Active, passive, auto desirable, and on mode. Active passive belongs to LSCP, auto desirable belongs to PACP, and on mode belongs to
the on mode.
on mode, right? Because it doesn't belong to any protocol.
Yes.
So now I said channel group 1 mode on. Now you will see that show Etherchannel summary.
Yes.
All of the links bundled to port channel 1.
Yeah.
Show spanning tree. Now you can see that switch 1 is treating this 4 switch ports as a single port.
Yeah.
Now you'll go to switch 2 and you will see that none of the interface is in blocking state. That's the problem.
Okay.
Port of switch 2 is still acting as independent ports, but you have configured the link bundling on switch 1 using on mode.
Yeah.
So now you can see the difference.
Yes.
So you'll see after some time, you can see this message.
Oh, okay.
Read it.
Okay, it says disable channel.
Yeah. E0/0, E0/1, E0/2, E0/3, and port channel. All of them are in
error disable.
Error disable state. Yes.
That's good. So the Etherchannel misconfigured, it works automatically, doesn't need to be enabled.
Yeah, because you haven't made the configuration on both sides.
Okay.
So switch 1 is sending one BPDU and it is receiving BPDU back from switch 2 side.
Back, yeah.
So you can see show spanning tree summary. Which feature is doing this?
Enabled. Okay.
Etherchannel misconfigured feature is by default enabled. So you can see show interfaces error disable. Show interfaces status error disable.
Yeah.
Because of misconfiguration, but it will create a temporary loop in the network.
Yes.
So go to switch 1, do one thing. Now remove this command. No interface port channel 1. Okay.
Yep.
And interface range shutdown.
Okay.
No shutdown. I've removed the configuration from switch 1 also. Now you can see show spanning tree. And you can go to switch 2. Now these 3 ports are again in which state? In blocking state. Right?
Yeah.
All of these ports are in blocking state.
And block.
Yes. Any confusion here? No. Right?
Oddly.
This time I'll go to switch 1 and switch 2. I'll make the configuration on both switches. Channel group 1 mode on. Interface range Ethernet 0/0 to 3. Channel group 1 mode on. Right?
Yeah.
I've done the configuration on both sides.
Okay.
Now we can see show spanning tree. Port channel 1. Show spanning tree.
Port channel.
Port channel 1.
Yeah.
Designated forwarding. Can you see? Can you see this?
Yeah.
Now the overall cost is decreased, right? Because for one interface cost was 100, but now you have bundled 4 interfaces together.
Okay.
So the overall cost will be decreased.
Okay.
See? Show interface Ethernet 0/0. What is the bandwidth here? 10,000 kilobits. If you convert it to Mbps, 10 Mbps, right?
Yeah.
We have bundled 4 links together of each of 10 Mbps. So you can see show interface port channel 1. What is the bandwidth of port channel 1?
Yeah.
40,000.
40,000 kbps. Yeah.
Kbps, right? If we convert it to Mbps,
it's 40 Mbps.
this is the total bandwidth. And throughput is
80
Mbps. Right? How can we verify the configuration? Show Etherchannel summary. You can see it here.
Yeah.
Here we have the flags. And here's the output.
Yeah.
Number of channel in use,
There's one.
1. Number of aggregator is 1. Group 1,
One.
port channel. Port channel 1, SU, capital S, means
Mhm.
because you have two types
Layer
of ether channel, layer 2 and layer 3.
Okay.
So you can see capital S is for
Mhm.
layer 2,
Layer 2.
right? And you can see R for
Mhm.
layer 3. So here we have S,
Layer
not
3.
R. S means this is layer 2 port channel. U means
Okay.
in use, because there is a small
In
s which is
use.
known as suspended. If your port channel is in down, you will say SB.
Suspend. Yeah.
D means
Okay.
U means in use.
Start.
All right.
In use.
Then P means bundled in
Port channel. Aggregating.
port channel. If you have 4 links,
To the
1,
port channel.
2, 3, 4. Okay.
Mhm.
This interface is in full duplex. Okay, Kovosto.
Yes.
This interface is also in full duplex. This interface is in half duplex. And this interface is in full duplex.
Mhm.
This is your E0/0, this is E0/1, E0/2, and E0/3. When you'll configure the link bundling, this port will
Mhm.
be,
Suspended.
so you will see here S, small
Yes.
s.
Okay.
So P means the interface is part of the port channel, and S means
Suspended.
suspended because of configuration mismatch.
Okay.
You can go to one of the interface E0/2. Duplex half.
Okay.
When you do this, you'll get a message. Read this.
It cannot bundle two. It is not compatible to Ethernet 0.0. It will be suspended. Duplex of Ethernet 2 is half, and Ethernet 0.0 is full. Understood.
So now if you'll run the command again, show ether channel summary. You can see E0/2 is now
Suspended.
suspended. So now if I go to the interface again and I say now you can see E0/2 is compatible with port channel members, right?
Full.
Now you can see it is back to the port channel. E0/2 is bundled in port channel now. Okay.
Okay.
Right.
Yes.
So this is the first method of configuration, which is on mode.
On mode, yes.
We can configure the same thing using PAGP. So what we can do here, we can go to switch 1 and you can say default interface range Ethernet 0/0 to 3 and no interface port channel 1. So this command is used to set the configuration to default.
Yes.
Same thing on switch 2. No interface port channel 1. See, you have to delete the port channel interface manually.
Okay.
When you remove the configuration from the switch port, it doesn't mean that your port channel interface will be removed explicitly. Right?
Yes, yes.
So you have to do it manually here.
Okay.
No interface port channel 1. Now, this time we will make the configuration using PAGP. Interface range 0/0 to 3. Channel. Now you got an option protocol, right?
Okay. Yeah.
Now you'll see that is it mandatory to define the protocol? No. Is it not mandatory? Okay.
Yeah.
You can configure it directly, but how is this command useful? See, if I'll define PAGP, and then you'll go to channel protocol, channel group 1 mode. If you'll try to define active, it will give you an error message. Command rejected because channel protocol mismatch. You have configured channel protocol as PAGP and you're defining the mode of LACP. So this command is useful to avoid the misconfiguration. All right. Okay. Which command? This one. If you have selected the channel protocol as PAGP, you could not define on, active or passive. Only mode you can define is auto, right?
Auto.
Yeah. Now see the difference. See the difference, Kagosto. I've made configuration on one side, right? So spanning tree, but still the interfaces are acting as individual
ports. Yeah.
You can see. So Etherchannel summary. Port channel is in down state right now because ports are in I means standalone. They haven't bundled yet. The ports are not bundled yet.
Okay.
All right. So once you make the configuration on both sides, only then you will see that bundles ports are bundled. Interface range E0/0 to 3. Channel group. This time I'm not giving the protocol. So you'll see that protocol command is not like you can say mandatory. Now the configuration is done on both switches. You can see it now. The ports are bundled, right?
And the port channel and bundled.
Show spanning tree.
One port.
Port channel 1. Show spanning tree. Port channel 1. But for this, you have to make configuration on both switches. Show Etherchannel summary. Which protocol is being used? PAGP.
Okay.
Right? This protocol is in use?
100%, yes.
PAGP.
Yeah.
If I try to do this, interface range, Ethernet 0/0 to 3, 1/0 to 3, 2/0 to 3. Channel group 1 mode. You'll get an error. Channel group limit.
Okay.
Because you can only bundle maximum 8 links.
8.
Yeah. Okay.
Okay.
Do show Etherchannel summary.
Yes.
You can only bundle 8 links in case of PAGP. Any confusion in the configuration commands?
No. Everything is clear, 100%. And usually, like in the lab, the order of how you configure the Ether channel, so that you don't get the error disabled while you're working on one switch and the other one, and like I think my first lab, I got stuck in this section because I was just getting an error. The Ether channel was just not coming up. I think it was because the order that I followed when configuring the Ether channel. So is it best to shut the ports, the physical ports down, and then complete one side and then go to the next side? And yeah, okay, cool.
This is the best approach you can follow to configure a port channel. All right. Do what before doing the configuration? Shut down all the interfaces. Then make the configuration on both side switches and then enable the ports. If you will do it like this way, you'll see that temporary loop will not be configured. But you have to do this thing only when you want to use on mode. Because temporary loop is only caused in case of on mode, right? Hello?
On mode, yes.
Yeah, so if you want to use on mode at that time, you should disable all the switch ports and make the configuration and then enable it.
Okay.
Yeah. All set?
Yes.
All right. Now we can make the configuration using LACP.
Okay.
Okay.
Yes.
See, LACP allows you to bundle maximum 16 links together. We'll see that what is the reason behind this. But right now, let's see the configuration commands. Remove this command from here. Remove the port channel interface. No interface port channel. One. Go to switch 1. Default interface range. No interface port channel. 1. Okay.
Okay.
All right. Now let's make the configuration of LACP. Interface range Ethernet 0/0 to 3. Channel group 1 mode. Either you can configure active or passive.
Passive. Yeah.
Sometimes if you're doing the lab, they have asked you to configure LACP in such a way so that switch 1 initiate. It means on switch 1 you should define the active mode.
Okay.
Right? If they have given it explicitly that okay, you have to configure, you have to create the port channel, but please make sure that switch 1 is initiating for it. It means on switch 1 we need to define active mode.
Okay.
Yes or no?
Yes. Yes, that's correct.
Yeah. Okay. Mode active. All right.
Yes.
You can see right now ports are suspended because you can see LACP currently not enabled on the
remote side, yes.
remote side. So you can see show spanning tree, show Etherchannel summary. All ports are suspended. Go to switch 2.
Okay.
Make the configuration.
Okay.
Channel group 1 mode. Active active or active passive, but please don't configure passive passive.
Okay. Yeah.
LACP sometimes take a little bit.
Okay.
Now you can see interfaces are in upstate.
Okay.
So Etherchannel summary, all of the interfaces are below. You can say bundled in the port channel.
Okay.
Right?
Yeah.
P means bundled in port channel. Show spanning tree. We have the port channel 1.
Yeah.
Active and up.
Yep.
All right.
Yes.
You can see they are member of code channel. That means layer 2 you means in use.
Yeah.
Shows spanning tree. Code channel 1.
Forward. Yeah.
So basically, this is switch 1. This is switch 2. You have 4 links here. Right, Kagosto?
Yes.
In a port channel, the traffic load will be all the links, right?
Yeah. Yeah.
If one of the switch port will goes down, the load will on the next
Available list.
right? If you have 4 links here, all of the links are sharing the load, but if this link will goes down,
Yeah.
only 3 switches are here.
Yeah.
3 switch ports. The load will increase on all these 3 switch ports, right?
Yes.
That's the problem with PAGP and auto mode. Sorry, because on mode. In PAGP and in on mode, you can configure That's why LSCP comes with the idea that you can bundle maximum 16 links. You can bundle maximum 16 links, right? Because if one of the link will goes down, the load will not be put on the next interface. It will be a new active port there.
Okay,
We'll discuss about it after load
join.
Balancing algorithm. Once we'll discuss load balancing algorithm, then we'll cover that how the 16 ports theory help us to deal with the failures. Okay.
Okay.
First of all,
Okay.
you know that in in Etherchannel, we have to follow load balancing algorithm.
Yes, yes, yes.
What this load balancing algorithm is doing? If you have links 1, 2, 3, 4, this is switch 2, right?
Yep.
This user 1, this is user 2. If this user is sending, for example, 100 packets, it doesn't mean that first packet will be going this, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. No, this is not how the load balancing works, right?
Yes.
You can't load balance the traffic like this, like first packet from this port, second packet, third packet, fourth packet, fifth packet, sixth packet, seventh packet, eighth packet, ninth packet, 10th packet, like this. No, the switch has to decide one of the switch port to forward all of 100 packets.
Okay.
Right. So that's why it comes. It's known as load balancing algorithm.
Okay.
This load balancing algorithms comes into the picture to decide which port will be used to forward which packet. So if we talk about this, how it will be decided? For that, let me create a table first. 2, 3. Number of links, number of bits, and output. If you have bundled 2 links, minimum you can bundle 2 links. How many bits will be checked? 1 bit. 0 or 1, right? If you have bundled 3 links, I'll explain it in a while, don't worry. You'll have total 4 values.
Okay.
0, 0, 0, 1, 1, 0, 1, 1.
Okay.
If you have bundled 4 links together, you'll be checking 2 bits. 0, 0, 0, 1, 1, 0, and 1, 1.
1.
If you have bundled 4 links, 2 bits are not enough. We are going to check 3 bits. So you'll have total 8 values.
Okay.
Sorry, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1.
1. Okay.
If we'll bundle 6 links together, again we are going to check 3 bits. See, you can bundle 16 links in case of LCP, but again, load balancing only supports 8 links.
Okay.
It doesn't matter how many links you have bundled together, but as per the load balancing, you can only have 8 active links.
Okay.
Okay.
Yeah.
Yes.
Understood 100%.
Now, what I mean by this, let me explain. This is switch 1. This is switch 2. All right.
Yes.
You have 2 links, 0/1, 0/2, 0/1, 0/2. Switch 1, switch 2. Now, here I have a user. Here I have a user. MAC address of this user is A, MAC address of this user is B. IP address of this user is 10.1, IP address of this user is 10.1.1.2. First time user 1 will generate an ARP request, right? Source IP is 10.1.1. Destination IP is 10.1.1.2. In ARP header, source MAC is A, destination MAC is 0000. But ARP header will be encapsulated with Ethernet header. So in Ethernet header, source MAC is A, destination MAC is broadcast, right?
Yeah.
This traffic will be delivered to switch 1. Okay. Now, first of all, switch 1 will learn the source MAC on this interface. Then switch will take the forwarding decision on the basis of destination MAC. Now, destination MAC is broadcast. Yes. So this packet will be forwarded out of all interfaces, right? Yeah. But this interface, now you see 2 interfaces are there, but this interface is acting as 1.
All interfaces.
Only 1 copy can be forwarded on the switch port, right? Now switch is confused. That which one use this interface or this interface, right? So by default, switch is using source MAC in load balancing algorithm. Okay. See, always remember, switch is not using source MAC to decide the exit interface. Switch is using source MAC to decide the interface in the port channel. Okay. So in port channel, how it will be decided that which interface is being used. So it will use source MAC. MAC is A, right? Yeah. If I convert A MAC into binary, see, A is not actual MAC. So if I say IP config This is how the actual MAC address looks like. Right?
Yeah.
This MAC address is having two sides, left and right. Left hand side, right hand side. So for load balancing algorithm, we are using always rightmost bits. Okay. So we'll convert it to binary. Binary of 8 is 1000. Binary of 10 is 101.
10.
How many links we have bundled together?
2.
So this 0 and this is
1.
This time I'll check only one bit.
Okay.
What is the value of one bit?
It's 0.
0. So traffic will be forwarded out of this. Traffic will be forwarded out of this interface. For example, if you have a user here with MAC address, for example, E. Source IP is 10.1.1.3. So it will forward traffic like this. Source IP is 10.3, destination IP is 10.2, source MAC is E, destination MAC is 00. This is an ARP request. Source MAC is E, destination MAC is. This traffic will be given to this, right? First of all, it will learn the source MAC on 0/, sorry, this is 3 and this is 4. MAC address is E. Now it will take the forwarding decision. To convert E to binary, E means 14 or 15, 14, right? 1, 1, 1, 0. Again, value is
0.
So again, traffic will be forwarded out of this interface. Etherchannel load balancing never Etherchannel load balancing algorithm never promise equal cost load balancing. Okay, it is just a fraction.
Okay.
So, for example, if MAC address of this is, you can say B, or we can say B, right? B is on this side. If this user will send traffic, source IP is 10.2, destination IP is 10.1. Source MAC is B and destination MAC is
A.
When this traffic will come to switch 2, switch 2 will say, okay, exit interface is port channel, but in port channel I have two interfaces. Switch interface will be used to forward that packet. Again, it will decide on the basis of
Source MAC.
B is the source MAC. So binary of B, for example, here we have B. So binary of B is 8, 4, 2, 1. What is the value? 1.
1. Okay.
This interface will be chosen, right?
Okay. Yeah.
Now in Etherchannel load balancing, you have many attributes. Like you can choose source MAC, destination MAC, source plus destination MAC, source IP, destination IP, source plus destination IP. Okay.
Yeah.
Source port number, destination port number, or source plus
Destination port number.
Destination port number.
Okay.
So sometimes in the lab, maybe they have asked you to change the load balancing attribute. You'll say, can we check this? Yeah, you can check it. Go to the switch and run a command. Show Etherchannel. Which is in use by default.
Okay.
See, most of the switches you will see that always by default they are using source MAC to decide the exit interface, right?
Okay. Yeah.
But this thing is also dependent on the operating system and the device to device.
Okay.
That's why in this we can see that it is using source plus destination IP.
Okay.
But if you go to the configuration mode, you can see port channel.
Load balance.
You have multiple options here.
Okay.
You have destination IP, destination MAC, source destination IP, source destination MAC.
Okay.
All right.
Okay. 100%.
Any confusion in this?
No, 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 no. It's clear. No, no confusion.
So you'll see that source port, destination source plus destination port number feature is not supported here.
Yes.
Because source port number, destination port number, source or destination port number is supported only on 4500 series switches.
Okay.
Okay.
Okay. No problem.
So you can change it from here. Because if you're seeing that source MAC is not able to share the load balance, share the load equally, you can change it to other values. You can use combinations as well.
IPs and stuff. Okay.
Yeah. So now if we come back to this, if you bundle two links, you'll get number like 0 and 1.
0 and 1. Yes.
If you bundle three links, see, if I bundle three links,
Get 2 bits.
switch 1, I can check 2 bits, but if I'll check only 1 bit, I can have only 0 or 1. So in that case, 0, 1,
1.
2. So if we'll only see 1 bit, we would not be able to forward traffic on this interface.
On this one, okay.
We need to check
2 bits.
But when you will check 2 bits, again you got a problem. If you check 2 bits, you'll get 4 values. But you have only 3 links. So this interface will be forwarding for 0, 0, 0, 1, 1,
0.
Who will forward for 1, 1? The first link.
Again, okay.
Yeah, so the extra load will be increased on this port.
Okay.
So that's why it is always
doesn't guarantee equal
recommended that you is always recommended that you should not bundle 3, 5, 6, and 7 links together. Either you bundle 2 links, 4 links, or
4 or 8 links.
8 links. Because if you bundle 5 links, this is switch 1, 1, 2, 3, 4, 5. So if you bundle 5 links, 0, 1, 2, 3, and 4. If you'll check only 2 bits, if you'll check 2 bits only, then you'll be able to use only 4 links. This link will always remain unused, right?
Yes.
But when it's at 3 bits, so in case of 3 bits, you'll get total 8 values. So this interface will forward for 000, 001, 010, 011, 100. Then 101, 110, 111. The node will be shared. Honey. Right. So that's why you should always bundle either 2 links, 4 links, or
8, just to get that equal balance. Okay.
Yeah. Is that clear?
Yes, that's clear.
Any confusion here?
No confusion.
So let me show you that what kind of tasks you'll get in the lab related to Etherchannel.
Okay.
Appreciate. Hello.
Yes.
Can you see this?
Yes.
At the end of the task, all Etherchannel between switch 101, 102, and 1010. So this is your switch 1110. Sorry, 110. This is 101, and this is 10. You have 2 links between them. Right?
Yes.
It is asking you to bundle all at the end of the task, all Etherchannel between switch 101, 102, and 1110 must be up and operational, including all their physical
member links.
Do not create port channels interfaces. Reuse those that already exist on the
switch.
Because the good news is that when you appear for the lab exam, you'll see that the device is having some pre-configurations. You don't have to make it all the configuration from scratch. So it is asking you that if port channels are already there, don't make any changes to it.
Okay.
When resolving existing issues, do not change the pre-configured negotiation
protocols.
If they have configured LSCP, so leave it as it is.
Yes.
If they have configured PAGP, or if they have used on mode, so don't have to change the method. All right.
Okay.
On Etherchannel that uses a negotiation protocol, tune its mode of operation for the shortest link bundling time possible. That it should take the shortest time period.
Okay.
To bundle the links.
Okay.
Okay. You don't have to do anything in this case. You just have to take care that how the interfaces are bundled.
Okay.
So in this you can see the last task is saying that on all Etherchannel that uses a negotiation protocol, tune its modes of operation for the shortest link bundling time possible. So shortest time will taken in the on mode.
Okay.
Because in case of PAGP, you will wait for other side. Likewise, in LSCP, will be waiting for the other side, right?
Yeah.
But once you use the on mode, in case of on mode, the switches are not waiting for any other device.
They come up immediately.
Yes.
Yeah.
All right.
Yes.
So it means we need to configure on mode. You'll see that they are never asking you to configure LSCP, PAGP, or on mode directly. They'll always try to make it a tricky question.
Okay.
You have to be careful while making the configurations. All right, Kabasto?
Yes, yes. So that question says on an Ether channels that use negotiation protocol, tune its mode of operation for the shortest link bundling time possible.
right? The on-mode takes the shortest time.
Okay, but they're saying use on the channels that use a negotiation protocol.
See, on-mode is also a method, so it is calling on-mode.
Oh, okay.
Yeah.
Okay.
Yeah. Because what do you mean by protocol? Protocol means set of tools.
Yes.
On-mode is also having its own set of tools.
Okay.
Right?
Yeah.
Yeah. So is it clear?
Yeah, it's clear. Okay.
All right. So that's all for today, Kobos.
Okay. Thank you, sir. So we're going to share these videos.
No, your voice is not clear. Can you say it again?
Oh, I'm saying, are you going to share this video?
Video?
Or at the end? Yeah.
Yeah, I'll
That we
upload the
did
video.
today.
Do you use Telegram?
Telegram.